ಮಾಡ್ಬೇಕಾ?
ಮಾಡಿ ನೋಡ್ರಿ.
ಹೌದಾ? ಪಾಸ್ ಆಗ್ತೇನೆ ಅದು?
ಈಗ ಸ್ಟಾರ್ಟ್ ಆಯ್ತು.
ಹೆಂಗೆ ಗೊತ್ತಾಗೋದು?
ಇಲ್ಲಿ ಒಳಗಿನ ಲೈಟ್ಗಳು
ಹಾಂ,
ಪಾಸ್ ಆತಂದ್ರೆ ಇದು ಹೋಗ್ಬಿಡ್ತೈತಿ. ಇದಾಗೋದಿಲ್ಲ.
ಬಂದು ಸ್ಯಾಟರ್ಡೆ ಎಲ್ಲಿ ಹೋದ್ರು? ಬರಲೇನ? ಸ್ಯಾಟರ್ಡೆ ಬಂದಿದೆ, ಬರಲೇ ಇಲ್ಲ. ಹಾಂ, ಇದ್ಲಾ ಕಾಣಿಸಿದ್ಲ ನೀ? ಆಮೇಲೆ ಒಯ್ದಲ್ಲ ನಾ. ಹೌದು ಹೌದು, ಜೋರು ಬಂತು. Morning. So today we will discuss about the place and also the basic source development of stress in human body and its consequences and their consequences. Then basic sources of occupational stress in work situation. And also we discussed about the design of the information displays, types of displays, there is visual displays, in that quantitative displays, qualitative displays, all that we have already, and the characteristics of displays, design recommendations, we have already discussed. So today we will discuss with the controls, that is the last part of this unit, design of controls. So here, so as we know, displays and controls are totally related to the machines which are being used by human beings. So we need our objective of ergonomics or the study in ergonomics is related to making the job fit to the human being. So while making the job fit to the human being, we need to make it so comfortable for the operator or the person who is using it, which includes design of controls and displays which are part of the machines. Most of the machines need to be designed in such a way that the usage of that should not cause fatigue to the operator or stress in the work situation or stress in the human being, so that he can maintain his efficiency throughout the working day. So the next part of it is design of controls. Design of controls. So in that what they say is a control is a device which transmits information to some mechanism, machine or system. Control is a device which transmits information or which transmits the information to some mechanism. Transmits the information to any mechanism or machine. So whenever we come to know with the display that, for example, that we are on the two-wheeler or maybe on the four-wheeler, we are going very fast, with say for example 100 kilometers per hour, that the display is the speedometer, which is showing that you are going above average speed or whatever, which is not good. So then immediately we need to use the controls by using which we can reduce, the human being can reduce the speed of a vehicle or two-wheeler or four-wheeler, whatever, or the machine. We need to reduce it. So for that we need to have a control, right? So here what they say, the control is a device which transmits information to some mechanism, machine or system. A control is selected based upon the nature of information desired to be transmitted. What type of nature? Uh, Nature of information is there. Whether the speed need to be reduced, whether the temperature need to be reduced, anything. It could be anything. So based on the system, based on the machine, or nature of the information, the controls are being developed or designed. After having selected the most appropriate type of control to use, it should be logically arranged and clearly marked and easily accessible. So it should be made easily available, accessible to the person who wants to control the device or control the devices, control the machine, control the system, or control the mechanism. So it should be easily accessible and it should be easily usable, right? And clearly marked which one need to be used. Then the control should suit the capabilities of the operator's limbs and should be positioned to distribute the loads evenly amongst them based on the capacity of the hand, arm, limbs or the wrist joint. Based on the requirement of all these, the control should be developed or designed so that it can be easily used by the human being for controlling the system, for monitoring and controlling the whole system or machine. Then there should the performance human operator depends upon the type of the controls provided by the machine. Of course, different types of controls provided by different type of machines. If it is lathe, then different type of machines are there, different type of control devices are there, incorporated. If it is a four-wheeler, for example, car, the control devices are different, right? Accelerator will be there, brake will be there. That is a control device. Brake will be the control device which will stop the car or reduce the speed immediately so that we can avoid the accidents, something like that. Uh, and the speedometer acts as a, or it is a device which is a display which is exactly in front of the operator or the driver, okay, which is showing the speed at which the car is moving on the road, which is and the human that which is not that with the display he has to perceive or he has to control the machine. Then types of controls. A wide variety of control devices is available use in human machine. A wide variety of control devices is available for the use of man machine system. Here, for example, different types are there. Types of controls. For example, one is crank, second one hand wheels, third knobs, fourth levers, then pedals, then push buttons, etc. These are the few examples of controls. Switches are also there. Cranks, is large and speedy movement is desired. The crank handle should be designed so as to move it freely by the human being. Need more space than hand wheel. Cranks are multi-rational in cranks. How cranks are wheel, to use, then hand wheels are also multi-rational. The rim the rim Okay, then hand wheels, I have understood. Then knobs. Knobs are the rotary controls. Rotary controls, for example, the fans. Are shaped circular or bar shaped, so you can do it like that. Reliable grip. So if we get the reliable grip, then we can easily have when load are light. So smooth and so adjustable that by moving little by some degree, less degree, then control the speed, whatever, of the machine properly. Then modern solid state ceiling fan. This is what it is. Regulators have the knob control. This is what I told. Levers. Levers may be spring loaded and rigid control type. Spring loaded ones require more space. Gear shifts in cars, those are the levers. Okay. Then in cars or machine tools, okay, gear shifting, throttle control, joysticks are the examples of lever control. Then pedals are spring loaded. Pedals are spring loaded. Okay, that you can understand, I think. A pedal is a reciprocating control operated by one foot acting independently. So as you know, in the car, the accelerator will be there, or the clutch will be there, or the accelerator, clutch and brake will be there. So each one will be operated by a single foot. Okay, okay, separately. This is how it is. Okay, pedals are operated by in standing position as well as while sitting. That can be done. Okay, while standing also we can operate some machines pedals to control the machine, and by sitting also we can do it. The width of the pedal is as large as shoe sole, and the length as much as 25 centimeters. So longer pedals, accelerator pedals of the car, are employed for continuous operation, and smaller ones for clutch and brake pedal of the car for intermittent operations. We are not using it. Accelerator continuously we are using. So the length of that will be little different. Then push buttons is a reasonably small control unit. It may be push on or on offload, push on, push off type, etc. The push button diameter is such that it can accommodate fingertip. Okay, just push button. Machine. Maybe, for example, hair dryer. So small knob will be there. So not knob actually, push button will be there. So you can change the speed by pushing the button. This is how it is. Then its surface is slightly concave like that. So that, okay, if it is totally horizontal straight, then it is very difficult to operate. If it is concave, then it is easy to operate. Then electrical machines have push on off machines. Then toggle switches are used to when bend positions are less in number, thereby rotary switches are being employed. And toggle switches are used for two positions. Okay, one is on and one is for off. Then rotary switch. Unlike the toggle switch, rotary switches. Rotary switches can have 24 positions. For each position, there should be preferably be an audible click regulators. We can listen to some sound is audible while moving it. This is how it is. We can easily understand we have switched. We have increased the speed by one step or two step or three step. Again, it depends. Given incorporated in the. Okay, then next one is selection of controls. Structure of controls. How, first of all, it's the characteristics of speed we expect on the machine. Based on that, we can select accuracy required, then force, range, load, and control functions. As we said, yes, we have listed, we have given it. Any books you can refer further. Then continuous control should be selected for making precise adjustments. Then controls should make use of each body member depending upon the physical capability limitation of each. Linear controls. Linear controls are used for a small range and rotational controls for larger range. Related controls should be combined. Then easily identifiable controls should be used. Machine characteristics should also be taken into consideration. Of course, machine characteristics are also required by designing the specifications. Right? Before selecting the tool, hand control should, however, that. Of course, in some of the cases, in ergonomics, what we say that better make your hands totally free so that the foot operated brake or something can be used. So your hand should be free to hold the handle or something like that. Otherwise, nowadays we find brakes will be incorporated in the hand itself for the two-wheelers. This is how it is. Then hand control is more natural than the foot control. Hand for most of the control activity. Then foot control may be used for hands and some task variation. Then hand control operation should preferably be with one hand, and two-handed controls, however, have more forcing capacity. Most suitable direction of the movement of the control is horizontal, back and forth. Or most suitable movement for the foot is down and up, away from the body in automobile cars and all. A foot control is preferred over hand control when continuous control of low precision is required. Foot can exert more force than hand. Now, so this is about the controls. So we have ended up with this. So tomorrow we'll see the anthropometric data. What is anthropometric data? How to use the anthropometric data? Working environment. What is housekeeping? The procedure for housekeeping. Right? And then we'll take up workplace. Okay? So that we will study later. And work design considerations also we'll study. So now I wanted to show you clear to understand. Uh,
cut with, or the seat that doesn't fit our bodies. Ergonomics aims to solve these kinds of problems. Named after the Greek words ergo and nomos, meaning the natural laws of work, ergonomics is about matching products and tasks with people. Ergonomics is a relatively new concept. In the early days of industrialization, getting the job done was more important than the well-being of the worker. Around the 1940s, people began to realize that work could be done more efficiently if the equipment was easier and safer to use. The science of ergonomics was born.
A key part of ergonomics is the usability of the systems we use. So when we come up to a product or system, we need to know what to do. We need to know that it fits us physically and will efficiently get the results we want. Ergonomists will configure the whole system so it works for the range of people that are going to use it, whether they're children, adults, whomever.
Many gadgets and appliances have an impressive array of features, but they can be difficult to figure out, even if you still have the instruction manual. This is frustrating, and it means that many features are wasted because the user sticks to the simplest tasks. To make things understandable, we need to consider the way people think and interpret the information. This can be as simple as using red for stop and green for go, because that's what people are used to. It also means designing so that people can do the obvious. This video camera lets us do what comes naturally, so it requires no detailed instructions. In this design, the places you might want to push to close the camera are marked with warnings to the contrary. The right place to push is even hidden under the strap. So layout is another important factor. On this stove, it's fairly simple to relate the layout of the controls to the layout of the hot plates. Here, the layout of the controls is oriented differently to the hot plates. We have to look more carefully to see which goes with which. In the control room of a power plant or on the bridge of a container ship, there's simply no room for confusion. The signals and warnings must be easy to see and interpret, or the consequences could be disastrous. It's your turn to feed the dog. Lucky for him, your hands are the right size for the handle on the can opener. And you're strong enough to twist the knob. But if it was your little sister's turn, or your granddad's, the dog may well be hoping for the day that you're back on the roster. The physical fit between us and our man-made environment affects us all the time. How well do our clothes fit the size and shape of our bodies? How comfortable is our furniture? Why are some things easier to grip and handle than others? How well do we fit into our workspaces? Are we working at a comfortable height? Can we reach the controls of the machinery? Are they easy to push and turn? Can we see what we're doing? If our equipment doesn't cater for our physical requirements, Even something as simple as adjusting a car radio can be a difficult and dangerous task. In order to match people physically with the products and work systems they use, we need information about people's characteristics. This information comes from the field of anthropometry. The word anthropometry comes from the Greek words anthropo and metrikos, meaning the measurement of humans. Ergonomics texts like this one contain anthropometric tables that describe the size of.
So about this anthropometry that we will discuss later. So today just we will understand what is ergonomics. So as you have seen the video,
So what
different
are
type
human
of
factors?
different type of knobs, switches, how they are useful, how they are integrated in the machine, how they are being used, how to design them, or you can say that how usage of the knobs, levers, or toggle switches, pedals are to be made so efficiently and effectively. Those can be used by the human beings. So the design should be such that they can be used, easily accessed and easily being used by the human beings, so to control the machine. That you have understood.
Your video for frontline staff will provide you with an overview of human factors and why they are relevant to us in healthcare. Have a think. Have you ever done something wrong because of bad design? For example, have you ever walked into a door thinking this is a door, but it turned out to be a school door? What about this design? What are the odds of picking the wrong medication rather than the right medication based on the design of those ampules? These are just a few examples of the huge science that is human factors and ergonomics. And this video seeks to define the terms human factors and ergonomics, describe their role in healthcare, and hopefully by the end you'll appreciate their influence on your performance as an individual, as a team, and at the system level. Human factors is a science that provides an understanding of what affects our performance and behaviour in the workplace. It allows us to better understand how we work, both mentally and physically, and how we can design our work environment and systems to maximise patient care, safety, and staff well-being.
And this video is showing about the healthcare system, how the ergonomics is useful in healthcare system, which is making the performance of the healthcare people more efficient and effective, so that it will help the patients to get easily, or you can say that the patients will be get cured easily, and whatever the machines are being used to treat the human being should be compatible with the human beings for using it, as well as for giving the treatment to the people or the treatment to the patients. This is what he is saying.
Our brains are incredible at being able to make sense of complex situations and multitasking. We're constantly jumping from one
And always the
task to another.
performance of the operator totally depends on how the job is fitted to the human being. Job in the sense it includes the machine, the system, the controls, the displays, everything is included in that.
Idea to an action to another. And you can understand why you feel so tired at the end of the shift when your mind is working like that, trying to juggle multiple tasks. But of course, that also means that sometimes we miss something, or we drop something. And what about when you're in as well? We understand that our cognitive functions can be impaired, and when we are patients, we may need extra support for everyday decisions and tasks that we wouldn't normally need in day-to-day life. And what about the world around us? How does that influence us? Understanding our strengths and weaknesses as humans and how we receive and process information allows us to better design equipment, tools, software, and physical environments for us and our patients.
So while designing any system which is related to the healthcare issues or whatever, So we need to understand the weaknesses and strengths of the human being. In particular, just generally, the human being strengths and weaknesses, and also anthropometry comes into
When
picture.
we read, our brain makes associations between all of the letters in a word that we are familiar with and allows us to read it quicker because we don't read every single letter. We can read this on the screen easily. But what about these? How about now? Medication labels is a great example of human factors redesign that helps us address the risk of how humans process information with those tactfully placed capital letters. Human factors is user-centered. It is about understanding how we are affected by the tools, tasks, and environment we work in, and the culture of our teams and organisations, and then takes that understanding to make the situation better. It allows us to understand how complex healthcare is, and how one part of healthcare, by changing it, can easily impact on another. We're going to look at three main components of human factors: us as individuals, teams, and then the wider system. So let's start with you. As a human being, we have limitations. The problem is that when we reach our limits, if we overcome our limits, we're far more likely to commit an error or not identify when an error occurs. A great way to think about this is to think that you have got three metaphorical buckets. And the fuller those buckets with stuff, the more likely you are to commit an error. One of your buckets is your self bucket. This bucket fills up depending on your expertise, how much skill you've got, how much knowledge you've got, and how much capacity you've got. Your second bucket is the context bucket. This fills up depending on the situation that you're working in, how much support you've got, what equipment you're using, and how is the environment around you
Very
designed.
nice.
And then you have your task bucket. This relates to the particular task you're doing. Healthcare is very task-focused, and fills up depending on the type of task you're doing, how complex it is, how likely an error is to occur, how many steps it takes, and how new is it to you. You can think about this before you go into any situation. How full are your self, context, and task buckets? The fuller they are, the more likely you are to do something wrong or not spot a problem. This is the point where you should ask for help to minimise the chance of things going wrong. Make sure you recognise your limitations. And then what about teams? What makes an excellent and effective team? A good team has clear leadership, is aware of the situation that's going on, looks after its team members, and communicates clearly. Leadership means making sure the team is working towards a common goal, making sure that team processes are used, for example, briefings, huddles, and debriefings. A good leader also makes sure the team is on the same page by monitoring the situation and ensuring everybody is aware of everything that is going on. A good team looks after each other. That means identifying when your colleagues need help, but also accepting help from you. It also means speaking up should you see anything that concerns you related to safety or quality. And all of this requires communication. Communication is about saying what you mean and making sure what you mean is heard and is actually undertaken. This is called closed-loop communication. And then finally we have the system. This is the wider world around you that is constantly changing, and you as a person have to constantly adapt to changes in the system. This is called resilience. We as individuals have resilience, we adapt to the world around us, but also the system that we work in adapts to the constant everyday changes. Look around you in your workplace. Who is there? What equipment are you having to work with? What protocols and policies are you following? What is the environment like? By identifying all of these different interactions, allows us to identify where there are factors that might inhibit our performance, but also factors that might support our performance in practice. Remember, human factors is about performance and about supporting your performance in practice through an understanding and then a optimization of the world around us. There is loads of work here related to human factors going on in the trust. Speak to the patient safety team, speak to the French Simulation Centre. Have a look at our emulation teams there. And please find out more about human factors and how they relate to you. The most
So the human factor and ergonomics video will give you the clear picture, what are the important qualities the system should have, or the people, those who are designing the system should have, so that they should not only concentrate on the design of the machine or design of the product, as well as the design of the environment in which the people are working, and how fit the total environment or the job, including the job, is fit to the human being. This is what they need to understand and then prepare it. And how the ergonomic factor influence the teamwork, that this video is showing. I'll explain it later once again. Okay, so tomorrow once again we will go through it and I will explain it. So today we'll stop here. Thank you very much. And tomorrow we'll take up the next part of the unit. Thank you.